This example, GATE 2015 and set 2 and question number 44. It is little bit ambiguous. Okay, please focus on this question. There are 4 instructions: multiplication, division, addition, subtraction. Fine. And 4 stages: instruction fetch, operand fetch, perform operation, write back. So only 4 stages. That means where are you doing decoding? Here in the first stage itself, and we are doing operand fetch in the second stage, and we are not doing memory operation. Probably you will be doing memory maybe in this write back stage. We don't know, right? That is not mentioned. So finally there are only 4 stages. That is sufficient for us. Now they are they are saying that we have to do operand forwarding between perform operation stage to operand fetch stage, PO to OF, that is operand forwarding stages. Okay. Now using this information we have to execute these instructions. Now we'll see this question which is asked in GATE 2015 paper and second set 44. So they have, it's not multiple choice question and they have given fill in the blanks. Multiplication R5, R0, R1 and division, addition, subtraction. 4 instructions. We have to find out number of clock cycles required. And there are dependencies. Then we have to go for operand forwarding. They have mentioned that we have to do operand forwarding between perform operation stage to operand fetch stage. Remember that. Okay. Only this forwarding is possible. Now they have mentioned that there are 4 stages: instruction fetch and decode 1 stage, operand fetch 2nd stage, performing operation 3rd stage, writing back 4th stage. Okay. Now one more extra thing they have mentioned that, so perform operation is taking variable number of clock cycles. For addition subtraction 1, multiplication 3 and division 5. By keeping these things in mind, we have to solve it. Okay. Simply fill this table. That's it. First instruction is very easy. We fetch here. We know that. Then after that, operand fetch, 2nd clock cycle. Then perform operation. Since it is multiplication, it requires how many clock cycles? 3. PO, PO, PO. Then later write back. Done. Now second instruction. So division. It requires 5 perform operations. That means 5 cycles for perform operation. So division R6, R2, R3. Is there any dependency? What are you reading? R2, R3. Are they got updated anywhere? No. Then there is no dependency. Then we can happily fetch normally like this. Fetch, then operand fetch, OF here. Then later perform operation. But already perform operation stage is busy. Then we will have stall cycles, I can say. Correct? After that, here perform operation, perform operation, perform operation. Since it is division, it requires 5 cycles. 1, 2, 3, 4, 5 followed by write back. Done. Now third one, addition of R5, R6. But R5 and R6 are the, I can say, destinations of multiplication operation and division. Then we have to wait for the perform operation of R5 and R6 because they will be only available after perform operation of multiplication, perform operation of division. And of course, the forwarding is possible. That's why we have to wait for PO stage. Let us wait. Just focus on PO stage of this one, instruction number 1 here, right? PO stage will be done here and PO operation will be done here, correct? So we have to start doing operand fetch here, I can say, correct? So that's why you write operand fetch here. Otherwise it is not possible. Then, but we don't know that, right? So we will be initially fetching here, instruction fetch. After that, we have to wait, you see. Don't do operand fetch here because data is not available. So I can say like this, instruction fetch, then wait. Right. So after that you do OF. After that, now what we have to do? Perform operation. Here happily we can do perform operation, then write back. Correct? Since it is only taking 1 clock cycle for perform operation, everything is good. Right? Now, what I want to say is, the 4th instruction, if you see R8, R7, R4, R7, R4 we are reading. Are we updating it anywhere? Yes. R7 is getting updated here. Be careful. Okay. Appropriately we'll plan. So we fetch the instruction here. After that we have to do operand fetch. But one thing, however, we can't do operand fetch. Already I told you, right? So we cannot do operand fetch unless this OF is done, right? So that's why wait. However, we will be doing operand fetch in the this clock cycle, correct? Before that you can't do. Though you can, if resource is available, we should not do, because between instruction fetch and OF, if you do your OF, then you will be, erasing the values of I3 instruction. Correct? That's fine. So we will be doing OF here. But the only thing is, data is available or not? Data is not available because I3 is doing perform operation here. At the end of the clock, I am assuming that, let's say, end of the clock cycle of PO, data is available. Then we have to wait one more cycle. Then we'll do perform operation here. Then after that, what else? Then we have to do here write back, isn't it? Try to understand. And one more thing. So here IF, OF, 1, 2, 3, 4, 5, 6. See here 1, 2, 3, 4, 5. Here OF, then here PO, then write back here. Yes, I3. I4 fetch is here. Then 1, 2, 3, 4, 5, 6, 7. We cannot do anything here. I have forgotten. OF is missing actually, correct? That is what actually we have to do here. Then in this stage we will be doing OF, right? Now to do operand fetch, data is already available. See why I am focusing on OF? Because data should be forwarded between PO to OF. Without data availability, we can't do OF. Understand? That's why. Now let me ask you, whoever attending my lectures, I am asking you this question. Why can't I do OF here? If you do OF here, then this perform operation is still, updating that R7 might be, correct? Then we can't do OF, right? Generally, right? Then we will be stalling. This is the, earliest time where we can do OF. After that, perform operation, then write back. So if this is the case, then answer is what? 15 clock cycles. This is the general answer, like, every time. So we'll solve the questions like this, right? Already we solved some questions like this. But in the question exam, in the key paper, they have given answer as 13. How can you get 13 as answer, right? So definitely, so to get the answer 13, based on the answer, I am updating myself or I am changing my answer. But so we can't, that's why it is an ambiguous question. Let me clearly tell you that it is ambiguous. Why they have given answer 13, then what is there in their mind, I will tell you now. So what is there in their mind to get 13 answer is, while doing perform operation, so maybe they are thinking about the circuit such a way that the perform operation is, updating the register file in the first half of the clock cycle. Did you remember in our theory, when we were learning the theory, we did the same thing, right? We were, having the clash between write back stage and operand fetch stage. Did you remember? And at that time I said that write back stage is writing the result in the first half and operand fetch is reading the result in the second half of the clock cycle. Then only that is possible. We get the right answers. Here also, let me assume like that. Perform operation is modifying or updating the results in the first clock cycle, and operand fetch stage is really reading the operands in the second clock cycle. Okay, second half, first half. If that is the case, then what is going to happen is, we don't really require to wait for this operand fetch to be taken here. We can take operand fetch here itself. My assumption is what this time, because they have given answer 13, I am trying to match that answer. To match that answer 13, then perform operation and OF can be done in same stage, and we assume that in the first half data is available, that will be given to this operand fetch. So in the second half, this operand fetch is reading the correct data. Understand? In that way, first half data is updated. Which one? This one is I3 instruction, right? Sorry, I2 instruction. And I2 instruction is using R6. It is modifying R6, right? So R6 is getting updated in the 10th clock cycle, first, especially in the first half cycle. Operand fetch stage of I3 is reading R6 in the second half of the clock cycle. Then only there will not be any clash and you get the right answer. Let us do that. So finally PO and OF are getting done at the same clock cycle. If that is the case, we will be doing perform operation here, then write back here, right? Now let us focus on this time I4. I4 fetch, then wait because see, between IF and OF or any instruction we should not do anything, right? Go for now OF. Can you do OF here? No, resources problem. Then wait. Then can we do OF here? Yes, I can do OF then. Why? Perform operation is updating the results here and we are taking the result in the second half of the cycle, no problem. So after that perform operation, since it is subtraction only one clock cycle, write back. Then answer is 13. So unfortunately, so in the question they are not mentioning all these details, but they are giving the answers as 13, right? So then what to do? What I suggest is, because there are two such questions, okay, so which are following this model, don't worry anything, because whatever we did is it's right. 15 also correct answer, 15 is also correct answer, 13 is also correct answer, only thing is what we are assuming. But if you ask me, sir, finally you tell me which one to be assumed, first one or second one, so that is what ambiguity. Okay, so what you do is in the exam, in the next paper, if they give this kind of question again, then solve this question with two models, okay, and tally the options, and which one is, I mean, really if there is a 15 answer in options, go for 15. If 15 is not there, if something else is there like 13, go for 13. Understand? So finally I would like to say that this question is ambiguous, and assume that yeah, we can do this problem in two ways.